Slope-intercept form. Graphing, writing, and using the slope-intercept form of linear functions. Let's start by graphing two lines, one of which is given in slope-intercept form, where m is the slope, b is the y-intercept. Let's graph the y-intercept first. So we'll put a dot at -1 on the y-axis. Remembering that slope is rise over run, from my y-intercept, let's drop down 4 and to the right 3 and place a dot. And now from my y-intercept, let's go up 4 and to the left 3 and place our third dot. Now if I was careful graphing these 3 points, they should lie in a straight line, and they do. So there is the graphical form of y equals -4/3 x minus 1. Notice the slope is negative, and as you read that graph from left to right, you can see that it's falling. So that's what a negative slope looks like. All right, and the second equation, it is not in slope-intercept form. So let's subtract 6x from both sides. To get y by itself, we have to divide all 3 terms by -5. Let's rewrite that equation as y equals 6/5 x minus 2. All right, so this is now in slope-intercept form. It's easy for us to graph. We'll start on the y-intercept of -2. And the slope is positive, so the rise over run is up 6 and to the right 5. And we'll place our second point. And there's no room on the coordinate plane to go down 6 and to the left 5, so we'll just connect these points, and that is the graphical form of 6x minus 5y equals 10. Notice the slope is positive. As you read that graph from left to right, you can see that it's rising. Here I'm asked to write the slope-intercept form of the equation, and I like to graph the line first, even though it's not required. It just helps me to make connections in the math. So I'm going to start with y-intercept of 3. Now my slope is -1/4, so let's go down 1 and to the right 4. Place our dot. And from your y-intercept, let's go up 1 and to the left 4. Place our third dot, connect those dots. So that's what the graph looks like with a slope of -1/4 and a y-intercept of 3. The equation of the line is best found by the slope-intercept form, where the slope is -1/4 and the y-intercept is 3. So you want to have y equals -1/4 x, don't forget the x, plus 3. Here we're given 2 equations, none of which are in slope-intercept form, but we're asked to graph the line. So let's write the equation of the line in slope-intercept form. We'll subtract 4x from both sides. Let's divide all 3 terms by -7. Let's rewrite the equation as y equals 4/7 x plus 2. We got a positive 2 because -14 divided by -7 is positive 2. So let's start on that y-intercept of 2. Let's use our slope. 4/7, rise over run, up 4. And when we go 7 to the right, we'll be slightly off the grid here when we place our second point. Now from your y-intercept, let's go down 4 and to the left 7 and place our third point. Let's connect the dots. So there we have the equation of the line in slope-intercept form, and we have graphed the line. Okay, now the next example is not in slope-intercept form. Let's subtract 9x from both sides. Let's divide all 3 terms by 2. And we're left with y equals -9/2 x minus 3. So we will start by graphing our y-intercept of -3. And typically, if the slope is -9/2, I would go down 9 and to the right 2. but there's not enough room on my grid, so let's rewrite the slope-intercept form this way, keeping the negative sign with the denominator. So when I graph, I'll go up 9 and to the left 2, and there's my second point. So understand, when a slope is negative, you can have the negative sign go with either the numerator or the denominator or out front, but you only keep the negative sign in one place. Now let's connect those dots, and there is the line that I was asked to graph. 9x plus 2y equals -6. All right, your final task here is to take a graph and write the equation form of it in slope-intercept form if possible. The first example will be possible because the y-intercept is on a lattice point. It is 0, 0. So the y-intercept is 0. I can measure my slope by looking for other convenient lattice points. There's one there, and there's one in quadrant 4 as well. And now when I look for the slope, you're going to start at a point, any point, and do rise over run to get to another point. So I'm going to start at the middle. I'm going to go up 4 and to the left 3. I also could have started at the middle and gone down 4 and to the right 3. Either way, the slope is -4/3, and the y-intercept is 0. So your equation is y equals -4/3 x. You also could have said y equals -4/3 x plus 0. That would have been equally correct. Now let's look at this interesting line on the right-hand side here. Will that line ever intersect the y-axis? Will there be a y-intercept? No, because it's parallel to the y-axis, so there will be no y-intercept. So this is one of these special case lines, and people always forget, is it y equals something or x equals something? Well, let's just find a point that lies on that line. Here's one. And the coordinates of that point are 3, -2, right? Let's find another point that lies on the line. Coordinates of this point are 3, 1. And let's even find another point that lies on the line. Coordinates here are 3, -4. Are you noticing it's the x coordinate of every point that lies on that line that equals 3? Therefore, the equation of this line is x equals 3, which can't really be written in slope-intercept form, can it? Just x equals 3.